Good morning. I am Hans H. Stein, an associate professor in the Department of Animal Sciences at the University of Illinois. And I'm here this morning to talk to you about some work we have done recently in which we measured the energy concentration and phosphorus digestibility in milk products fed to weaning pigs. This experiment was conducted by myself and my two co-workers, Dr. Bob Kim and Young-Woo Lee, who is a graduate student here in the Department of Animal Sciences. The work I'll talk about here will consist of a short introduction. I'll then talk about an experiment we conducted to measure energy concentrations in the milk products. Then we will talk shortly about a project in which we measured the phosphorus digestibility in the same three milk products, and then finally a few conclusions. As a little bit of background, when milk is processed, we get different products coming out of that processing procedure. First, if raw milk is made into cheese, the casein in the milk and most of the fat is removed and going into the cheese. So what we are left with is a whey, which consists of the lactose, a little bit of protein, and also the ash that is in the milk. From that whey, the whey proteins can be removed to produce whey protein concentrate, and that will leave us then with the whey without the whey proteins, and that product is called whey permeate. The whey permeate consists mainly of lactose and ash, and if the ash is removed from the permeate, then we will get a lactose product, or a product that contains mainly lactose. If we look at the composition of three of these different products, then we can look at whey powder as it's coming out of the cheese production and it's been dehydrated, and that product usually has 95.8% dry matter. It contains 3,647 calories per gram of gross energy. There's about 13% crude protein, 15 to 16% ash, and a little bit of calcium and phosphorus in this product. Now, as I said before, whey protein concentrate can be produced from whey powder by extracting the crude protein out of whey powder. And if that is done, we are left with a permeate. And in this case, we used a permeate called Perlac 850. And Perlac 850 is a typical permeate containing approximately 97.7% dry matter, 3,426 calories per gram of gross energy, and the protein is down to 4.3% because most of the protein was removed from the whey powder. There's 8.96% ash left in the product, so some of the ash was also removed. And calcium and phosphorus in this product is down to 0.42% and 0.57%. The last product we used was called Variolac 960, and Variolac 960 is produced by removing most of the ash from the Perlac 850 product. And now we have a product that contains 98.4% dry matter, 3,657 calories per gram of gross energy, a little over 3% crude protein, and only 1.7% ash. And then calcium and phosphorus here is down to 0.11 and 0.10% because most of the ash was removed. So from this, it appears that the majority of the dry matter in Variolac 960 is lactose. So lactose in Variolac 960 is about 95 to 96%, whereas lactose in Perlac 850 is only 85%, and lactose in whey powder is about 72%. The objectives of the work we conducted here were to measure the DE and the ME in the three whey products that I just showed. And we also wanted to measure the standardized total tract digestibility, which is also called the STTD, of phosphorus in each of the three whey products. In the first experiment, we measured energy concentrations in the three products. In this experiment, we used 32 weanling barrows. They had an initial body weight of 9.2 kilograms, and they were placed in metabolism cages as shown here in the picture. Each cage is equipped with a feeder, so we can measure the amount of feed that each pig is provided every day. There's a slatted floor, and below that floor there's a screen, so we can collect all the feces from the pigs. below the screen there's actually a funnel so we can collect the urine as well. And that allows us to calculate the digestible and the metabolizable energy that we have in these diets. We used 4 different diets and we had 8 pigs per diet. The diets we used consisted of a basal diet, then we had a whey powder diet, Perlac 850 diet, and a Variolac 960 diet. The basal diet consisted of 60% ground corn, 28% soybean meal, 8% fish meal, and 4% vitamins, minerals, a little bit of fat, and other products. We then took 70% of the basal diet and 30% of each of the 3 whey products to formulate our 3 test diets. So the whey powder diet consisted of 70% basal diet and 30% whey powder. The Perlac 850 diet consisted of 70% basal diet and 30% Perlac 850, and Variolac 960 diet consisted of 70% basal diet and 30% Variolac 960. The results from this experiment, results are shown in this chart. We have the digestible energy and the metabolizable energy, and these data are on an as-fed basis. The blue bars are for the digestible energy and the orange bars are for the metabolizable energy. Digestible energy is calculated by subtracting the energy in the feces from the energy intake of the pig, and the metabolizable energy is calculated by subtracting the energy in the feces and in the urine from the energy intake of the pig. We have the amount of energy on the left-hand side here and each of the 3 whey products along the x-axis. For the whey powder product, we can see that the digestible energy was 3,494 calories per gram, whereas the metabolizable energy was 3,317 calories per gram. The Perlac 850 product contained a little bit less energy, and there was 3,177 calories per gram of digestible energy and 3,009 calories per gram of metabolizable energy. And both of these values were significantly lower than for the whey powder. However, when we went to Variolac 960, we see that the energy increased compared with the Perlac 850, so we had 3,626 calories per gram of digestible energy in Variolac 960 and 3,537 calories per gram of metabolizable energy. If we look at the data on a dry matter basis, we'll see that the whey powder contains 3,646 calories per gram of digestible energy and 3,462 calories per gram of metabolizable energy. Perlac 850 contained 3,253 calories per gram of digestible energy and 3,081 calories per gram of metabolizable energy. And Variolac 960 contained 3,683 calories per gram of digestible energy and 3,593 calories per gram of metabolizable energy. And we can see here again that the values for whey powder and Variolac were significantly greater than the values for Perlac. And the reason we see an increase in energy when we go to Variolac compared with Perlac is that the ash was removed from the product. In the second experiment, we measured the digestibility of phosphorus in the same 3 whey products. In this experiment, we used 32 barrows, and in this experiment, the pigs weighed 11 kilograms at the beginning of the experiment. And again, the pigs were placed in metabolism cages, exactly like before, but this time we collected only the fecal materials from the pigs and not the urine. Again, we measured the feed intake of each pig and we collected the fecal materials over a 5-day period. We had 4 diets and 8 pigs per diet in this experiment. The diet we used was a diet based on whey powder, a diet based on Perlac 850, and a diet based on Variolac 960, and we also had a phosphorus-free diet in this experiment. The diet based on whey powder contained 44.5% cornstarch, 30% whey powder, and then there was sugar and soybean oil and a few other ingredients included. All vitamins and minerals were included in this diet. to the recommended levels, except that there was no phosphorus added to the diet. So all the phosphorus in this diet came from the whey powder. Perlac 850 diet was formulated using the same principles, again with 44.5% cornstarch, 30% Perlac 850, and sugar and soybean oil and a few other ingredients. And for the Variolac 960 diet, we used exactly the same composition, and the only difference was here that the 30% whey product was Variolac 960 instead of Perlac 850. Again, in all of these three diets, the only phosphorus in each diet was provided by the whey product itself. We used a phosphorus-free diet that consisted of 29.2% cornstarch, 20% lactose, 20% sugar, soybean oil, and 26.8% other ingredients, and 20% of these other ingredients was actually gelatin, which is a phosphorus-free source of amino acids. We also had quite a few synthetic amino acids in this diet to make it as balanced as possible. The reason for using the phosphorus-free diet is that by feeding the phosphorus-free diet, we could measure what the excretion of phosphorus from the pigs were if they were fed no phosphorus, and we could use those values to correct the data from the other three diets. Results from this experiment. The results are shown in this chart, where we have the digestibility of phosphorus in each of the three products. The blue bars represent the apparent total tract digestibility of phosphorus, and the orange bars represent the standardized total tract digestibility of phosphorus. You see for the whey powder, the apparent total tract digestibility was 84.3%, and the standardized total tract digestibility was 91.2%. For Perlac 850, the apparent total tract digestibility was 86.1%, and the standardized total tract digestibility of phosphorus was 93.1%. And in the Variolac 960 product, we had 55.9% apparent total tract digestibility of phosphorus and 91.8% standardized total tract digestibility of phosphorus. So what we see here is that when we look at the apparent total tract digestibility, we had about the same values for whey powder and Perlac 850, but a much lower value for Variolac 960. However, when we look at the standardized total tract digestibility, there were no differences among these three products. The reason we get a different result when we look at the standardized total tract digestibility compared with the apparent total tract digestibility is that all values for the standardized total tract digestibility are corrected for the losses of phosphorus from pigs that were fed the phosphorus-free diet. And by correcting for these losses, we get a little bit greater value in all products for the digestibility, but this correction means a lot more for Variolac 960 than for the other two products. And the reason for this is that the concentration of phosphorus in Variolac 960 is lower than in the other products, and therefore the correction for endogenous losses increases the digestibility proportionally much more than for the other products. This also illustrates why it is more correct to formulate diets based on the standardized total tract digestibility of phosphorus compared with the apparent total tract digestibility of phosphorus, because the values for apparent total tract digestibility of phosphorus are influenced by the endogenous losses, which is not the case for the values for the standardized total tract digestibility of phosphorus. But again, overall, for all three products, we saw a very high digestibility of phosphorus, above 90% on a standardized total tract digestibility basis, and this is much greater than what we will find when we look at vegetable feed ingredients. So all three products are excellent sources of digestible phosphorus. A few conclusions that we can draw from these two experiments. We have seen that the metabolizable energy on an as-fed basis was 3,317 calories per gram for whey powder. That was greater than in Perlac 850, which was only 3,009, but the whey powder had a similar ME value compared with the Variolac 960 product at 3,537 calories per gram. All three products can be used in diets fed to pigs, but if Perlac 850 is used, we have a little bit less energy compared with using whey powder or Variolac 960. For phosphorus, we saw that the digestibility on the basis of standardized total tract digestibility was 91.2, 93.1, and 91.8% in the 3 products. If we convert that to percent of standardized total tract digestible phosphorus in the products, we can do that by multiplying the digestibility values for phosphorus by the total concentration of phosphorus in the products. And when we do that, we see that we have 0.57% standardized total tract digestible phosphorus in whey powder, we have 0.53% in Perlac 850, but we have only 0.09% in Variolac 960. So with these data, we can formulate diets for weaning pigs using either whey powder, Perlac 850, or Variolac 960. Each of these products are supposed to be valuable products in weaning pig diets, and now we have data for both the metabolizable energy concentration and the standardized total tract digestibility of phosphorus in these diets. I'd like to thank you for your attention. I hope you find this information interesting, and I would like to draw your attention to our website where you can find a lot more information about nutrient digestibility in different feed ingredients and many other issues related to swine nutrition.